So it covers lectures 1 to 4, which includes today's lectures. Today we're going to review microorganisms and fermentation. And there's a lot of material to be covered in one lecture. So I really recommend to read the chapters assigned, which are chapter 5 and 4 in the book. I would like to start with a short introduction on history of the study on the fermentation, the alcoholic fermentation. You take now wine as a granted thing, but I would like you to think about the first time man observed wine or fermentation. Think about that man maybe 3,000 years before Christ that for a change decided to make juice out of grapes and make a full pot of grape juice. He couldn't drink it all the same day, so he let it sit there, and he came back 3 days later and he found this pot of grape juice doing very funny things. First, he would observe it was bubbling like it would be boiling. And he touched this pot, and he feels that the pot is warm. Second surprise. And then he's very curious, and he tastes this grape juice. And he keep following track of this phenomenon. And after a few weeks, he noticed that the sweetness of the grape juice, the grapes were very ripe beginning with, the sweetness has disappeared. And there is a very peculiar new flavor in it. And this new substance has also very peculiar effects, especially when you drink too much of it. So this whole phenomenon happened in a spontaneous way. And just to summarize, there is a gas evolved, there is evolution of heat, the sweetness disappears, and there is the appearance of a new substance. You can imagine how intriguing this was, and as a matter of fact, it attracted the attention of many scientists. And it was not until the 19th century when this very mysterious phenomenon was unveiled. By the beginning of 1800, chemistry as a science was already well developed, so Lavoisier could, in the, say, just to keep track, 1798, he could determine the substance that were involved in it. He determined it was sugar, it was glucose and fructose, the sweet factor in the grape juice, and the gas involved was CO2, and the new substance was alcohol. Gay-Lussac in 1890 and 10, he postulated for the first time an equation, chemical equation explaining this phenomenon. This formula may represent either fructose or glucose. This is a gas involved, and this is ethyl alcohol. So the first time it was known what was the chemical change involved in fermentation. But the main question, what was the causing agent of this change, was still unknown. And the presence of yeast in the fermentation was already known. As a matter of fact, a very clever man, a Dutchman, by the year 1680, very early, with a very primitive microscope, he could observe yeast for the first time. His name was Leeuwenhoek. So the presence of the yeast was known, but it was still not identified as a causing agent of the fermentation. And the first man to propose that yeast was a causing agent was Cagnard-Latour. And he said that the yeast present during alcoholic fermentation was a plant, a microscopic plant, and that the conversion of ethyl alcohol, the conversion of the sugar into ethyl alcohol and CO2 was a function of its physiology. This theory, which was known as the vitalistic theory, was very strongly attacked by organic chemists of that time, among which were Berzelius, Liebig, and Wohler, who really said that the fermentation was purely a chemical process. You all know about Louis Pasteur and his work, and the importance of this man, whose main research was done between the year 1857 and 1876. He postulated that yeast was responsible of the alcoholic fermentation. And by doing that, he discovered for the first time the existence of life in absence of air. Because alcoholic fermentation, as it occurs spontaneously, is an anaerobic phenomenon, which is there is air that does not participate in. In 1897, the Büchner brothers, they prepared a yeast extract which was able to ferment glucose in absence of any living cell. And that was the beginning probably of biochemistry, and it shows that the change of glucose into alcohol is a very complex chemical change which involves many different reactions. It's not only one step, but involved in the metabolism of the yeast cells many different steps which are catalyzed by enzymes. So now we know that yeast cells are the causing agent. And let's define what a yeast cell is. Traditionally, they have been classified as plants, lower plants. Nowadays, this statement is in discussion because yeast, along with other organisms, microorganisms, they are far more primitive than plants, so they are considered as protista, which is a category which is not either plant kingdom or animal kingdom. Yeast cells are widely distributed in nature, and there are about 350 different species, which belong to about 39 different genera. And this is not a very large number concerning species, either protista like protozoa, or other fungi, or algae, even bacteria. Their species number are over the 10,000. The fact that the fermentation will occur spontaneously indicate that the yeast cells is coming in the grape. So, and right now, there is enough information concerning the ecology of yeast. And we know that yeast is distributed in nature widely in plants and in soil. So the yeast cells is present already in the skin of the berry. There are many genera involved in fermentation. I'm going to mention a few of them. Lectura, Pichia, Hansenula, Torulopsis, Candida. And I'm writing in separate place the genus which is the most important, which is Saccharomyces. These genera are known to the winemaker as wild yeast. And this is known, I'm going to write the main species too. This is the so-called wine yeast. The reason for this name is because even all these genera are present in the berry, the one that will dominate and predominate along the fermentation is the Saccharomyces cerevisiae, even though it's in less number than compared to the wild yeast in the berry. But at the end of fermentation, it's going to be the only species that will predominate and will ferment glucose completely into alcohol. So it will be able to ferment up to, say, 10 to 14% alcohol. While yeast usually will ferment up to, say, 4 to 6% of alcohol. So this one will ferment to dryness, which is the total disappearance of glucose under certain conditions. Another property that characterizes this wild yeast is generally they have an apiculate shape, in opposition, in contrast to Saccharomyces cerevisiae, which is usually round, a round cell or slightly oval. Now we know that yeast is a causing agent, but why does yeast ferment or change glucose into alcohol? What is the reason for the yeast cell doing that? And this is, the reason for this is that yeast needs energy to grow. And by grow in microorganisms, we mean multiplication. So it has to reproduce itself, and for that it needs energy. Glucose is a universal nutrient or energy source for living organisms. and you can consider this a fuel that has to be burned in order to get energy. But in order to burn a fuel, you need oxygen, air. And in this case, in wine fermentation, there is no air present. If this is wine or grape juice fermenting, there is very little oxygen dissolved in the grape juice to begin with, and it's going to be used up very fast. And then the CO2 evolved. It's going to form a blanket on the top of the fermenting mast, and that will prevent the contact with air. So it's anaerobic. So we have that sugar has to be converted in an anaerobic way into alcohol and CO2. I'm going to write in boxes the reagents, products, and reactants of the equation. As a result of this conversion, in the absent air, we have that about 57 kilocalories are produced. And part of these energies evolve as heat, and the rest is used up in metabolic requirements. That's about 35% of the total energy is used as, for the metabolic requirements of the yeast. And this process is known as fermentation. If air is present, means oxygen, glucose can be burned completely into CO2 and water. And the amount of energy is about 12 times greater than in that case. Say 673 kilocalories. So when air is present, and this, we define this as respiration. When air is present, the cell is a lot more efficient and will be able to get a lot more energy per mole of glucose. Therefore, it will need less glucose to grow, and it will grow in larger amount than in absence of air. The effect of oxygen in the degradation of glucose is there is no alcohol produced, there are more cells produced, and less glucose is used up. And that is called as a Pasteur effect, the effect of oxygen in the utilization of glucose. And this fact that yeast cell can grow in the presence of air or in the absence of air bring us to the fact that we have to define this as a facultative anaerobe, which means that it can grow either in presence or absence of air. The grape juice, as a culture media, provides the yeast cells of everything it needs. So it's an ideal growing medium for the yeast cell. We have as nutrients, first, the fermentable sugar. We have nitrogen source. We have vitamins. and minerals. And that is, in brief, what the yeast cells need to grow. Fermentable sugars, the main ones are glucose and fructose. This is about half amount of glucose and half amount of fructose in grape juice. The nitrogen sources are ammonia and amino acids. Vitamins, any vitamins the yeast cell will need is present there. Even biotin, that sometimes is limited for the growth of yeast. Minerals, they are all present, and the main one is phosphate. The reason why phosphate is so important is because the way the cells use up the energy is by trapping this energy in the form of a compound which is called ATP. So ADP, adenosine diphosphate plus phosphate, traps the energy as ATP. But phosphate is present in grape juice. In the case when other fruit juices are fermented, sometimes it's needed and has to be added. The physical conditions on during the fermentation are very peculiar. There is a very low pH to begin with. Grape juice has a very high acid content. High pH, and like I said before, it's also anaerobic. Yes?
Please write bigger.
Okay. It's anything in particular you want me to write again? Okay. Well, high pH and anaerobic. Oh, I'm sorry. Low pH implies high acidity. Temperature is between around 80 to 85 degrees Fahrenheit. If the temperature goes over this range, if it goes up to 100 degrees Fahrenheit, the fermentation will stop. The yeast cells will not be able to grow anymore, and you will have what is called by the winemaker a stick fermentation. And that is a problem. So usually you need to control the temperature. In a small amount of grape juice, there is more dissipation of heat, so it's easy to do it. But in a large amount of grape juice, in a big tank, there is less dissipation of heat, so sometimes you need to cool this. You have to control the temperature and to keep it at an optimum range, or sometimes even lower than this, because at lower temperature, like say between 70 and 75, you are likely to get better quality of the wine. In the actual practical situation, generally, Saccharomyces cerevisiae is inoculated. So we have this species isolated, and we are going to inoculate it to the wine in order to favor the growth of Saccharomyces cerevisiae over other yeast cells or wild yeast. So we have that for practical purposes, inoculation has the following advantage. It's a more prompt So the advantages are the following. For more prompt fermentation, it will start earlier and faster. It's going to be more predictable, and the yeast cells, Saccharomyces cerevisiae, are going to predominate over undesirable microorganisms, and that involves wild yeast and other organisms that might be present. The yield of the wine fermentation is the following. The weight of a molecule of glucose is, of a mole of glucose is 180 grams, CO2 88 grams, 92 grams of alcohol. If you calculate the yield, how much alcohol you get from that much glucose, you will find that it is 51.1%. This is theoretical yield. In practice, it's about 47%. So 47% of your glucose is going to be converted into alcohol, and the winemaker uses the following formula to calculate how much alcohol he is going to get from his must. Alcohol percent equal 0.55 times the Brix degree. Brix degree is the grams of dissolved solid per 100 ml of must, grape juice. Probably, yes? Okay. Alcohol, Brix degree is grams of dissolved solids, which in this case are mostly sugar, but not all sugar, per 100 ml of grape juice. I said before that grape juice at the beginning has a very high content of acid. And that is a barrier against the growth of many organisms. There are very few organisms that will be able to grow at that low pH. But at the end of fermentation, there is one more barrier, which is a high alcohol. So wine by itself low pH Wine is characterized by a low pH between, say, 3 and 4, and by high alcohol content around, say, for the average wine, 12%. These two chemical properties of wine are a barrier against growth of organisms. There is a very important fact about wine. There is no pathogenic organism, pathogenic to humans, that ever has been found in wine. So there will no organism be able to ferment, to grow in wine that cause any disease to man. But there are a few organisms that will be able to grow in these conditions. You all know that if you leave wine sitting in an open container, it will convert into vinegar. So let's talk about now bacteria in wine. What the acetic acid bacteria does, it converts the alcohol into acetic acid. And this is now an aerobic process. You need oxygen to do this. This is an oxidation. And as a matter of fact, the acetic acid bacteria is an obligate aerobe. So it can only grow in the presence of air. The main genera are Acetobacter, and Acetomonas. A well-known species, Acetobacter aceti. These bacteria will grow in the presence of air on wine, and they are alcohol sensitive. They will not grow over, say, 14% alcohol. So in wines containing high amount of alcohol, they will not grow. They are also, say, let's write here, first, alcohol sensitive. And they are also SO2 sensitive. SO2 is an additive, and it's used for many purposes. One of the purposes regarding this aspect of winemaking is, first, it will inhibit the wild yeast. The Saccharomyces cerevisiae, the wine yeast, is more tolerant to SO2. So by adding SO2 at the beginning of fermentation, you are facilitating the growth of Saccharomyces cerevisiae over other yeast. And it also prevents the growth of acetic acid bacteria. Another way to prevent the growth of acetic acid bacteria is by storing the wine in closed containers and also in filled-up containers. So with very little amount of air present, the acetic acid bacteria will not grow. Nowadays, in modern winery situation, the acetic acid bacteria, the spoilage, is very easily avoided by doing this. So it's very unlikely you will find acetic acid or vinegar flavor in a wine you will buy in the store. But if you leave that wine open, sitting on your kitchen table, it will probably ferment. It will probably be converted into vinegar. Because the acetic acid bacteria are very widely distributed. So there is another organism that might grow in wine and this is the only bacteria that will survive the alcoholic fermentation. This is a lactic acid bacteria. One of the two main acids present in grape juice are tartaric acid and malic acid, also in wine. Malic acid is about half of the acid content of wine. It's a decarboxylic acid, means it has two acid groups. And this acid is converted in the absence of air because lactic acid bacteria is microaerophilic, which means it will grow under very little amount of oxygen. It will be converted, fermented into lactic acid. So as you see, by this fermentation, you are losing one acid group of this acid, which is evolved as CO2. So the acidity of the wine is reduced by the fermentation of the malolactic fermentation into about 1/3 in certain cases. This is malic acid. This is lactic acid. The overall reaction is called the malolactic fermentation. The lactic acid bacteria tolerates relative high content of alcohol. So it will grow on, say, wines up to 14 degrees of percent of alcohol. And it also tolerates low pH. So it might grow under various circumstances in wine. And since it will reduce the acidity, it will be an advantage to have malolactic fermentation when the wine is high in acid. In certain regions of the world where wine are usually very high in acid, like in Germany, where the climate is very cool and the wines, the end of fermentation, are still very high in acid, the malolactic fermentation is usually desirable because it will reduce the acidity. It also might add let's say, complexity to the flavor of the wine by causing very pleasant or relatively pleasant flavor changes in the wine. So there are two main advantages. But this is only of an advantage if it will happen before the wine is already in the bottle. If the wine is already in the bottle, it will cause turbidity or cloudiness and also gassiness. The gassiness is due to the evolution of CO2. So if the wine is in the bottle, it's a very undesirable feature to have malolactic fermentation. And it's also a disadvantage if the wine is low in acid to begin with. You don't want to have your acid content to decrease even more. Another reason why it's very undesirable in the bottle is because it might cause very undesirable flavors like sauerkraut flavor, for example.